Hello, today I'm going to follow the tutorial for SVG for HTML from w3schools. On Google I search for w3schools SVG, the first result. This is the wiki page. It's a file format with extension SVG or SVGZ. It's an image. The image can be resized as you want without losing quality, because the image doesn't have all of the pixels specified. Instead, it specifies that in here there's a line that's straight, vertical, with a given width and a given color. And this is a circle that's filled. So it uses geometric shapes in order to define the content of an image. It's plain text format. It's using XML and is supported by the web browsers, and you can use SVG HTML tag inside valid HTML web page. Let's see how that looks like. So this is an HTML5 sample HTML page. This part, the first 3 lines and the last 2 lines. Then there's a heading 1, which is this one. And then the SVG part. So the HTML tag SVG, which defines a size. So we want this part of the HTML with width 100, height 100, so a rectangle. And in there we will have one circle with a center X, a center Y. So these are the X and Y coordinates of the center. So X goes like this, Y goes like this. So it's 50 pixels this way, 50 pixels this way. So this is the coordinate of the center. And then there's a radius of 40 that provides a circle. And then we say that the stroke will be green. So the circle itself. And then inside the circle we'll have filling, yellow color, and the stroke, so the part that's the circle itself, is 4 in width. And this is alternative text if the web browser does not support SVG. So that was our very first SVG HTML tag inside a valid HTML web page. We should know a bit of HTML and a bit of XML. SVG is scalable vector graphics. And being part of an HTML page, it does integrate with CSS and JavaScript, etc. It's used often for icon sets, for logos, for backgrounds and other gradients, other HTML art that must look great on mobile phones, on TV screens, on all sorts of form factors and resolutions. We can create SVG files using an editing program. The program for editing SVG, which is open source, is called Inkscape. It looks like this. It's a WYSIWYG. What you see is what you get editor, and also shows the XML, so the SVG source code, which is in here. This image is not what you would expect. This is not actually a circle. This is not actually a line, but in fact, it's the SVG file, the XML file is being just used as the storage medium for this graphics editor Inkscape. So it doesn't really look like you would expect, because there's just one HTML element in here, which is called a path, with very complicated floating point coordinates. But if you would be to create these images yourself using Inkscape, then you would use shapes such as a circle, rectangle, stars, etc. You would set colors and brushes, etc. Okay, so as we saw, we can embed SVG directly into HTML, and this is what this tutorial does. It shows the SVG file format, it shows the various parts of SVGs and valid SVG syntax and the various geometric shapes that you can have inside SVG, but for usage inside an HTML page. This is the exact same SVG as before. Let's first understand this page. So again, this is just boilerplate HTML5 file format. The first 3 lines, the final 2 lines. This is a heading 1, and then this is an SVG part that's inline inside the HTML. It says that there's a namespace for SVG, which means that this circle is part of this namespace. In case you will have in here inside the SVG tag elements which are both valid SVG and valid HTML, such as, I know, image, IMG, circle, etc. Such that it knows where to fetch the tag from. So it should prefer to take it from the namespace SVG. We specify that the inline SVG is a canvas of 100 pixels by 100 pixels, so a square. And then we're painting just inside this canvas, just a circle starting with center at coordinates x and y 50 and 50, radius 40. The circle itself is going to be green, the inside is going to be yellow, and the circle itself is going to have a stroke which is 4 in width. Okay, we are going to use lowercase for the SVG tags, and we're going to use double quotes for the values of the attributes. Let's try to actually write all of these examples ourselves by installing a editor. We're using Visual Studio Code, and then we want to see the HTML preview. Once we save the file, we want to see the HTML preview of the HTML page that we're editing. I have installed Visual Studio Code. I have started Visual Studio Code. I have one directory with one file, a.html, and I want to see both the HTML in human readable format, so as it's displayed by a web browser, but also the HTML source code at the same time. For that, in the Visual Studio Code extensions, I have installed this extension, Live Preview, which is maintained by Microsoft ms-vs code.live-server. And it says in the first screen recording here that there's a preview button similar to what's available for markdown files, for files with extension .md. It's going to be available for files with extension HTML. Okay. Let's see how we can have side by side both the documentation, which is the tutorial that we're following, and the work, which is Visual Studio Code. So right half of the screen is Mozilla Firefox following the tutorial. Left half of the screen, Visual Studio Code with both the a.html file open as source code and previewed in a web browser. Okay, let's zoom a bit the fonts. My screen recordings are 1080p, so make sure that you're following my tutorial on a large enough screen such that you can see the text inside the YouTube video. Okay. So this is just standard HTML. You can put any HTML you want in here. And it also shows preview. I do not even need to save the file, which is great. And then there's the SVG. We can tweak it a bit. Let's make it way larger. Make just the so we're keeping the same center for the circle, and the radius was increased by 100 pixels, which makes it get out of the 200 by 200 rectangle, which is provided for SVG parts of the HTML page. So we can see that if the SVG body is larger than what we have reserved for the SVG content, then that extra content will not be showed. So it's going to be clipped. Okay. And for now, we had just one element inside the SVG, which is the circle. We can have multiple elements. We can have text. We can have rectangles. We can have circles. And there's an order. If you're, in this case, if you have a rectangle, it's going to be shown first, and then there's a circle that's fill yellow is going to be shown on top of the rectangle, and then there's a text that's going to be shown on top of everything else. So this is on top of everything until this point, then circle becomes on top of everything, and then text becomes on top of everything previous to it. So this is a Z order. So let's do what this example says. So there's no H1 anymore. Control X twice. The SVG width is 150 by 100. we're always going to have this part, the XML NS, and the same URL for the namespace. And now let's do our things. So we have a rectangle. There's no auto-completion, which is not that great. Let's see how we can fix this. So I wanted auto-completion for SVG tags. That is not provided out of the box by Visual Studio Code. There's an issue that's tracking adding support for SVG tag inside HTML. Not shipped yet. But there's an extension for SVG, which is called just SVG, with the name jock.svg, has many installs, and provides support for syntax highlighting for the language SVG. So let's start copy pasting from the right half of the screen to the left half of the screen. So rect with auto completion 100% width. That would be the entire SVG tags rectangle, so 150 by 100 width and height. Okay, and we want fill green. Rectangle 100% and fill green. Something very strange here. Yeah, the rectangle has a too large radius. Okay, so let's continue copying. So circle CX75, CY70, radius 40, fill yellow. Let's see a bit also the documentation. If you hover with the mouse on top of elements, create circles based on a center point and radius. And it also takes you to the Mozilla documentation. Provide by SVG extension. So a D is missing in here. It should say provided by SVG extension. Okay, let's continue with us copying text. Circle CX, CY, R, and then just fill nothing else. And then on top of everything else, there's text. $75. Even if the value of the attribute is a number, you should enclose it in double quotes. Font size 30. Text anchor middle. Red. and the text. Okay, let's see if this is what it should be the result. And it resembles, but not really. We're using another font family. This is without serif and this is serif. So it should also specify the font family. Let's see how we do that. Sans. Yep, like this. The colors don't seem to be perfectly identical. The green is not this green. And this is also serif. Okay, so we have until now the geometric shapes, circle, rectangle. You can use rectangles to create squares, of course. And then there's text. The midpoint of the text. The middle of the text should be 75 by 60. So 75, that's OX, and 60, that's OY. So it's this center of the text. But then why is it not exactly the same center as the circle? Because then it's two way up, X and Y. So X and Y is probably the coordinate of yeah, I don't know why it should be here 60. But that's how the sample does it. That's how we're going to do it. Okay, so we have fields for the interior of the text, fill for the interior of circle, fill for the interior of the rectangle. Okay, and previously we had strokes, and the stroke of the text is not visible, just the interior of the text, just the fill. Let's see how stroke works. And the stroke color, okay, that's the color. Let's make the font size bigger. Okay, so many of the SVG elements have both a fill and a stroke. For the text, not intuitively, the stroke is not displayed by default, but the fill is displayed by default. Whereas when you're creating a circle, you mostly want to see just the stroke, not the fill. Okay. Let's see what comes next. Next page. So there are the shapes rect, circle, ellipse, line, polyline, polygon, and path. You can convert many geometric shapes, for instance, into a path. The way we saw previously, a path can be used for anything. If we delete this element, then all of the black parts of the image disappear because everything is just one path. But a very complicated one with all of these elements inside the path. Rect is rectangle, pretty self-explanatory, circle, self-explanatory, ellipse, line. We'll see above these complicated ones. Let's look at the rectangle. X, Y, the left top corner, width and height, and as a feature, it knows how to show rounded rectangles. There's a radius X and a radius Y. Let's see this rectangle. So SVG 300 by 130. And then a rectangle 200 by 100. And it starts at X and Y. Then Y equals 10. And the corners are not rounded by default. The Rx and Ry values are 0 by default. Let's see just Rx equals 20, nothing else. Okay, not evident what Rx is and what Ry is. Two. 30. Yeah, it's not immediately evident, but it's evident that if you want to have a circle as the whatever symmetric shape as the rounding, you will need both Rx and Ry to have the same value. Maybe if you don't specify Ry equals Rx by default. Let's see, 40. Okay. And fill blue. The radius of the corners of the rectangle. Let's talk a bit about the coordinate system. The same coordinate system that has existed since monitors that can do pixels. This is the OX. and this is the OY. So OY grows from top to bottom, and OX grows from top left corner of the monitor, or of, in this case, the SVG HTML tag towards the right. So this would be 10, this would be 30, and this would be the coordinate 10 by 30. Next up, rectangle with a border. Rectangle with a border. You just specify the stroke and stroke width. Okay, let's do something similar to this without any CSS, and then we'll introduce CSS. So SVG 320 by 130, rectangle 300 by 100, then 10, teal blue, and we have stroke and stroke width. So stroke is a color, and stroke width is a dimension 3 in this case. Okay, so we can reproduce the same output by using just the rect SVG tag, or we could introduce inline CSS. Let's see how that works. These three parts, we'll convert them to CSS. Style, and let's see, fill, RGB, auto completion seems to work okay. Red, green, blue. 0 red, 0 green, maximum blue. Stroke color, red, and stroke width value 3. Okay, so we have just introduced inside the SVG tag rect the attribute style, which contains CSS. CSS fill, CSS stroke width, CSS stroke. Okay, rectangle with opacity. There's CSS styling for the rect, the same three attributes, properties as before, fill, stroke, and stroke width. And then there's two additional opacities, one for the fill and the other one for the stroke. Let's see that. 150 height for rectangle by 150 height, which means it's a square. Okay. So we want fill blue and fill opacity 0.1. So that was the fill, and now the stroke. Stroke pink. Stroke width 5. And stroke opacity 0.9. The opacity is in the range 0 to 1. Let's see what opacity 1 means. What opacity 0 means for the stroke. So fill opacity 1 means that there's no transparency. 0 means that you do not see the fill at all. 0.1 means that you see 10% of the fill, which is just blue. And in this case, for the stroke, you see 90% of the color pink. That was if we specify opacity for fill and different opacity for stroke, but we can set the same opacity for both fill and stroke by just using the CSS property opacity. Let's do that. 300 by 170, 150 by 150, 1010. Fill blue, no fill opacity. Stroke pink, and no stroke opacity, instead just opacity. There's this help if we hover on top of opacity, on top of stroke width, on top of fill. Fill paints the interior of the given graphical element. Stroke paints along the outline of the given graphical element. Yeah, very helpful. The fact that we have auto-completion, the fact that we have a bit of documentation if we hover with the mouse on top of the symbol, and the fact that we can instantly see the updated HTML without even saving the a.html file. Rectangle with rounded corners. (300, 170, 150, 150, 1010, and now we have the rounded corners. Rx is 20, Ry is 20, so we don't need to specify it. Let's see the style, fill red, stroke black, stroke width 5, and opacity 0.5. Next up, so that was the rect, now we're seeing the circle. Radius and x and y coordinates of the center. Let's also do this example, 100 by 100. Circle 45, CX 50, CY 50. The default value for CX and CY is 0. So this is the center of the circle. Coordinate 0 by 0, x equals 0, y equals 0, of the point where the SVG HTML tag starts being rendered. Okay, CX equals 50, so we're moving the center to the right 50 pixels. And now we want to move the center downwards 50 pixels. Next up, a stroke. Let's see that 100, 100, 45, 50, 50. Fill red, and we add the stroke. Stroke attribute defines the color of the outline of the circle. The default value is none. Color none. Okay. And the default value for stroke width, we can already see the stroke. It's green, but it's, I don't know, 1 pixel width. Its default value is 1. Stroke width, the width of the outline of the circle. This text in the documentation, when you hover on top of identifiers of elements, attributes, etc., is not perfectly rendered. For this, in this case, it says if A is used, and probably in here there's a, I don't know, percent. So the correct text would be if a percent is used, the value represents a percentage of the current viewport. So there's words missing in this text. And I'm not sure where the text is taken from. Where it says that the default value is 1. Doesn't say about percentage. So I'm not sure where the text of the hover is defined. Maybe in the source code of the SVG extension for Visual Studio Code. But this is a bug that should be fixed to see the correct text in this documentation hover. Okay, so we have circle with 3 values, R, C, X, C, Y. There's a fill, which is the interior. There's a stroke, which has stroke width. We did opacity. There's general opacity. There's opacity for stroke, opacity for fill. Like this. Or like this, just the fill is transparent, or might be the stroke. Now just the stroke is transparent. Next up, something similar to the SVG circle tag. This is the SVG ellipse. Has two radiuses, not just R, but Rx and Ry. And then it continues to have a center Cx and Cy. Let's see that. So I did a ellipse with X radius defined. And I'm not sure what the default value for Ry is. Okay, so I still don't know what Rx is and what Ry is. Let's look at an example. 140 by 500. Ellipse 150. Let's do the C-axis first. 120, CY 80. Okay, RX 100. And it doesn't look like an ellipse. Because it has two R-axes, okay. RY 50. Okay. It's the other way around. Height 140 and the width is 500. Okay, so we need a larger SVG viewport because it's an ellipse and it's wider than tall. So CX CY 120 80, which is this point, and then different values for the X and Y of the radius. The radius X is probably this thing from the center to the extreme right of the ellipse. So this would be 100 pixels, and then CY would be from the center to the top part of the ellipse, which is 80. Which is 50. Okay, so it makes sense. It's using CSS to style. Yes, let's see that. Fill yellow. Stroke green. And stroke width 3. Okay, and now it's creating ellipses, and the newer one wins. So the last one is on top of the others OXYs. There's a OX coordinate which goes from here towards the right. There's an OY coordinate which goes from here towards downwards. And then there's an Z order, which is the OZ coordinate in a 3D space. The uppermost that's completely visible SVG tag is topmost in Z order. So the last one, the newest one, is completely visible because it's topmost. Let's do this. So height and width 150 by 500 and many ellipses. CX 240, CY 100, RX 220, RY 30, and fill purple. Let's copy this line 3 times. Okay, the second ellipse, CX 220, CY 70, RX 190, RY 20, and fill lime. To 20, 70, 190, 20, fill lime. Not sure what's happening, why I don't see 2 ellipses. Maybe the smaller one is just... I don't have an explanation. RY 15 and fill yellow. Let me try to figure out what the issue is. The ellipses are not closed. Yeah, so the HTML clients, the web browser, allows you to not close some HTML tags, but in this case, the rules on how the web browser automatically closes the ellipse SVG tag when I did not close it are not immediately clear to me. Okay, next up, 2 ellipses. This looks like something that could be useful in logos and icons. Let's see how this is implemented. So 2 ellipses, one on top of the other. One is fill white, the other is fill yellow. So one is this one, the interior one, and another one, the exterior one. The interior one is on top. Height 100, width 500, 240, 50, 220, 30, and fill yellow. And the second one, 220, 50, 190, 20, and white. Next up, line. So says x1, y1, x2, y2. A line starts at position x1, y1, ends at x2, y2. Okay, let's do this. So SVG height 200, width 300, and we only have a line. X1. Do we need to specify x1 if the value is 0? Let's try this. And it's as I expected. The default values for x1 and y1 are 0, so you don't really need to say xy is 0 and y1 is 0 because that's the default values. And maybe also x2 and y2 have the default values 0. In this case, the line would be 0 pixels inside if you don't specify neither x1, y1, x2, and y2. So it would not be visible. Horizontal line. So horizontal means that the OY axis is not used. We're using the OX axis. Starts here, ends here. Increases the OX towards the right. So height 50, width 300. X1 is 0. Y1 is 10. We're keeping the same Y for Y2, which is 10. X2 is 250. And then for style, stroke red, stroke width 12. Makes sense. Vertical line doesn't variate the X, so X1 equals X2. The Y is different. So X1 is X2 is 0. And Y goes from 0 to 200. Height 210, width 300. Stroke red, stroke width 14. Makes sense. Polygon. Let's see how polygons works. made of straight lines and the shape is closed, automatically connects the last point with the first point. At least 3 sides. There's just one attribute, points. Polygon with 3 sides is a triangle. 1, 2, 3 points. And then from the last point, from the third point, it automatically closes the shape by going with a stroke towards the first point. Let's see this thing in action. Width 500, height 220. Polygon. Points. Okay, and points are pairs x and y. So x1 100, comma x2 10, space, but that was x1 and y1. So x2 150, y2 190, space, x3 50, y3 190, and we want the style. We want fill, stroke, purple, and stroke width. Okay, so that was a triangle. This is just a shape with four points. Let's see this. So height 260, width 500, a polygon, fill lime, stroke purple, stroke with 3, but with different points. 220 and 10. 300 and 210. 170 and 250. 123 and 234. For a second there, instead of 4 points, I had only 3, like this, and it was a rectangle. So make sure you're respecting the syntax of the points attribute. Polygon with 6 sides. Okay. And we need to change the viewport width 360 and height 280. And polygon star. Wow. The dimensions of this SVG tag always change. Maybe you should just start with large values and stick to that, like, I don't know, 600 by 600 always. with 500, height 210. Okay, stroke width 5, fill lime, stroke purple. And this is where we introduce a trick, which is fill minus rule with a value even odd. So 210 by 500, probably the same points, ends with 198. Fill lime, stroke purple, stroke with 5, and this is the new thing, which is fill rule even odd, which has actually not filled the interior of the star, the interior most of the star. Let's see how this thing is defined. Winding rule algorithm. Which parts of the canvas are included inside the shape? Non-zero or even odd? And non-zero is probably the default value. Okay, with non-zero we have the lime color also in the interior most of the star. Otherwise we don't. Okay, so we did line with diagonal, vertical, horizontal, and now we have polyline with points. And the polyline does not close automatically. From what I see, this shape is not closed automatically, and this shape is also not closed automatically. Let's make this large enough, 600 by 600, always. Fill none. Fill none is not the same thing as not placing a fill. So you must always specify fill none. That's very, very strange. So the default filling is black. That's a very strange decision. Three and green. Next up, polyline with fill. Only straight lines. And fill yellow. Stroke red. And width of the stroke 4. And path. Let's see what this does. This has an entire programming language hidden inside this attribute D. There's move to, line to, horizontal line to, vertical line to, curve to, smooth curve to, quadratic Bezier, smooth quadratic Bezier, elliptical arc, and then close the path. So an entire programming language similar to printf C programming language function. A DSL, domain specific language. So path that starts at 155, then does a line to 75 to 100, a line to 225 by 200, and then a Z, this guy, which returns to the first position. Let's see how that works. So path, and then a D, and where is the start? Move doesn't draw lines, it just puts a point at that position. So it moves at that point and that's it. Nothing is being drawn. Hopefully. Let's see if that's the case. So yes, indeed, just M doesn't paint anything. Okay, and then we create from that position 150x and y equals 5. We draw a line to 75, 200. And then another line to x equals 225, y equals 200. And then we return to the initial position. Okay. Bezier curve. Smooth curves. One or two control points and two endpoints. If you have just one control point, and that's a quadratic. The endpoint, start point, endpoint, and then control point B, just one, which means a quadratic Bezier. Wow. And Bezier is with Q or T. Where is the Q? This thing. And lowercase values are relative and uppercase values are absolute. And you can put a space between the watt and the first coordinate. Like this. Let's see where it says about the casing of these values. All of the commands above can also be expressed in lowercase. Uppercase means absolute positions, x and y. Lowercase means relative positions, I know, relative to the previous point, probably. How do we do the Bezier thing? So A to C. This thing. So a path, then the attribute D moves to this point, 100 by 350. Then it does a Bezier quadratic with relative values 150 minus 300 being the control point and the endpoint being 300 0 relative to the previous point, which is the start point. So the points are 150x and minus 300, so this guy, and then plus 300 and 0 OY for the endpoint, for the point C. Let's see everything. So the Bezier is this one with quadratic. And then they have IDs. So it says AB, this part. BC, middle, and the label, which is text A, B, and C, and the 3 black dots, the dot for B, and there's grouping, a way of specifying the same values for attributes, the same fill black for 3 circles. You use G, fill black, you end the G, and inside all of these will have fill black. The same for the texts. Font family sans serif is going to be a common value for the property for all of these 3 texts, A, B, and C. Okay, and text in this case specifies the absolute coordinates of some points that we know. For instance, this one, 100 by 350 is the coordinate of its point, which is the coordinate of this dot. We can see circle and the center is at 100 by 350. And then there's text that's also shown at 100 by 350. So exactly here is the text being shown. But then there's a delta of minus 30. So the X, the start of the text, is 30 pixels towards the left of the center of this black circle. C is going to be to the right, so dx is plus 30. And then for B is going to be above. B starts here, but then it's moved dy minus 10 pixels. So that's the OY. On the OY axis, you're going to go upwards 10 pixels. Which shows that the positioning of the text, the X and Y values are for the center of the letter and the bottom part of the letter. Which is, I would have expected that the coordinates for text start at the top left corner of the letter B, but no, it starts at the bottom center of the letter B. Wow. Something's not correct. Okay. Complex because there's a ton of coordinates. If you want complex graphics, do use an SVG editor such as Inkscape, instead of computing all of these pairs of X and Y coordinates by hand. Whatever, you need to compute them on paper first. Then there's text. X and Y, we know, are the bottom center pixel. The X and dy is the delta from that pixel. So if you want the text to be above the X and Y point, 10 pixels, then you're going to go dy equals minus 10. Vertical shift from previous text position. Okay, you can rotate each letter of text. If you have a fixed width for the text, that's text length. And if the text is longer than text length, this is the strategy to be used to fit the given text length. Okay, so let's see what it's doing here. There's text and it's red, so the red is the fill. Let me write it by hand. Text X equals 5. So the bottom center coordinate fill is the color of the text. And the text is going to be serif, which means the L is going to have these lines, horizontal lines, and the V and G also. Like this. Okay, next up, we want no fill, but we want a stroke. So this would be similar to a neon effect or a shadow or subtitles text. Let's see how that works. text 530 fill none. The fill is black by default. Yes, the fill is black by default. Red stroke and make everything bigger. Yeah, this doesn't look great because not all of the parts of the text have the same width. So this probably requires font family like this. Text width, fill and stroke. Fill pink, stroke blue, font size 35. I love SVG. Makes sense. Rotate each letter, not the text. Rotate attribute. And that's probably degrees, not radians. 530. Fill red. No stroke. Font size 35 and rotate 30. So indeed it's 30 degrees from the vertical. So it's vertical and then almost 45 degrees, 30 degrees. Rotate the whole text using transform. Wow, and transform is an entire programming language in its own. X30Y, X5Y30, fill red, font size 25. And now it's the thing. Transform. A list of transform definitions that are applied to an element and the element's children, separated by white space and or comma. Applied from right to left. Okay. Do we have auto-completion in here? Nope. Okay, 30 space 20 comma 40. Okay, so just provides, the tutorial just provides the function rotate and goes on. SVG text tspan. Tspan is a child of text or a tspan. Let's see an example and then we'll read. So text x30, 530, fill red, font size 35. I love. And then there's a tspan. Equals none. Let's close the tspan. Okay, inside the tspan we have SVG. Stroke green. I love SVG. And there's an extra space somewhere, probably this new line thing. So any white space is transformed into just one space, even if it's just a new line. Okay, so let's see what it did. So it contains a SVG tag text, but then inside we want a T-span. So part of the text that we're displaying, the entire text is I love SVG exclamation mark. Part of it, just SVG, will have different values for the properties. So the fill is going to be none, not red. The stroke is going to be green, not black. No. What's the value of stroke by default? Probably white. None. The default value of stroke is none. So if you want to have complex text styling, render a text along the shape of a path. Text path has 6 basic attributes. Wow, a ton of things. href, the URL to the path to render the text. Now this is introducing an interesting part of the SVG specification. We already saw very briefly the ID attribute where we had the Bezier curve, and now we also have the href. We saw length adjust previously for the text. We saw text length for the text. Default is auto. Space between glyphs. And it can start at the start of the path or after a number of pixels. Length, percentage, or number. Let's see an example. Wow, and what an example it is. Let's write it by hand. Starts with a path. We are using ID because we want an href. So this is Bezier curve. Moves to this point, which is 3180. Then a quadratic relative 150 minus 250. It's not returning to base, and it's going to 300 by 8 by 0. So quadratic with just one control point and then the endpoint. Okay. Fill is by default black. Stroke is not visible by default, which is interesting. Because stroke is none by default. stroke width 2, and we have the quadratic Bezier curve. And now we're going to put text along the path. But again, the path needs to have an ID because we're going to use the href for the text path. Let's see what is this thing doing. So says text, style fill red, font size 24 pixels, and we end text. And then there's text path, href, line AC, start offset 80, and the text. Yeah, I'm not sure why this thing does not work. The capitalization is really strange with lowercase t and uppercase p for text path. Use text path inside of text. Text is just not being rendered at all because we're not specifying, because it's shown on top of position 0, 0. Wow. Which means we want to move the X towards the center. The path doesn't close. Wow. So indeed, text renders outside of the SVG render area, so outside of this rectangle, because it's displayed on top of coordinates 0 and 0, which means in here. Okay, and the text was offset 80, which will move the text a bit further down the path, the quadratic Bezier. Text path, this thing. Okay, text along a path 2. I'm not sure what this change is trying to do. It says that text length should be 100%, but I don't see this thing working in the screenshot. So the screenshot is wrong. The source code is correct, screenshot wrong. It says start offset 20, so it starts from the start of the Bezier curve path, leaves 20 pixels, and then it starts writing I, LOV, etc. and says text length is 100%, which means it must spread the text for the entire length of the path. Let's remove this thing that's not visible. Path ID line AC. Values stroke blue. Fill none. Text fill red. Font size 25. Text path. Text length start offset. I don't know, it doesn't work for me correctly. This is not what I expected. It says text length 100%. And I can see only these characters. So O, V, SVG are not being shown. I'm not sure what's wrong. So the text length makes everything, all of the characters be spaced between the ton of space between characters, and then not all of the text is visible. There's no documentation for text length. Okay. Next up, there's similar to HTML, there's links. So A, href, it's similar to the HTML A tag, but different. This is an SVG, but still, if you click on it, it does things. It navigates the web browser to this URL, w3schools.com/graphics. So A, this target underscore blank we have seen before in HTML. And then inside there's a text. But you could have circles, etc. Everything wrapped inside an A. Like in this case, there's an A and inside there's a circle. The image in SVG is called image, not IMG. So in HTML, the name of the tag is IMG. In SVG, the name of the tag is image. There's JPEG, PNG, and other SVG files used to insert an image inside an SVG by using this href, the URL of the image. Let's actually see this thing. We need the absolute URL of this thing. Okay. And image is similar to just one geometric shape that you can paint. You can put Bezier curves on top of it, rectangles, etc., or below the image. There's a circle, an image, and a text. Okay. On top, there's this layer, which is a text. Underneath, there's an image. And then there's a circle. Height, width, href. And marker. Start, mid, and end of a line, path, polyline, or polygon. With defs element definitions. Marker start, marker mid, and marker end. Marker has 6 basic attributes to position and set the size of the marker. ID, height 3, width 3, ref x 0, ref y default 0, and orient 0. Angle. So this could be used to create such shapes, the lines with arrows, arrowheads. Marker, marker inside of defs, and then line, you say marker start and marker end. Yeah, let's see this thing. We have a line, we have marker start, marker end. The URLs are invalid, so probably this is a no-op. Doesn't do anything. But then if we add the divs, let's put just the arrow. And as you can see, the arrow is oriented correctly. And that's done by orient auto probably. Indeed. If I don't say orient auto, it's going to orient horizontally. Otherwise, it's oriented. So the marker is for the end. So it's looking at this entire SVG tag, which is line, which has a certain orientation. Okay, and this is the simplest marker, which is just a circle. What does marker width do? I have no idea. Height of the viewport into which the something is to be fitted when it is rendered. Okay, and this arrowhead is drawn out of what is this? Move, line, line, and Z. So it's a triangle with move and 2 lines. Fill black. Yeah, you should know that such things exist, but not really needed to memorize anything what's happening in here. But you should definitely know how to create a circle, a path, a line, and know that URL of ID exists, marker, start, end, and mid exist, and depths exist. This is an advanced topic. Mid marker, there's a polyline and finds the mid. You don't have to compute the mid, it's going to compute the mid automatically. Let's try to create a mid. Let's see how we do that. Marker mid, URL, circle. And it doesn't work because why? Because lines don't have a mid. I don't know. But this polyline does have a mid. Okay, next up. Fill attributes. We saw fill opacity. We saw fill. Fill could be none or a color. There's fill rule for odd even. Almost everything has a fill. Circle, ellipse, path, polygon, polyline, rect, text. So not line. Line doesn't have a fill. Text does have a fill. And polylines have a fill, and that's also strange. Color name RGB hex. We can put the fill inside CSS. Fill lime, fill blue, fill red. Fill opacity could be % or 0 to 1 a float, so 0.5. Like this, 0.6 and 70%. Fill rule, just two values, even, odd, or non-zero. We saw this thing. Stroke, we saw stroke, which is none or color. Stroke width 4 pixels, stroke opacity, we saw it. And then there's additional values for the stroke to create dashed lines, dotted lines, line cap. Almost everything has a stroke, including text. And stroke is the default value that the stroke is not visible in text, but is visible by default in a line. Okay. Path with move and then lowercase l, which is line relative. Stroke width, we saw 4, 5, so this is pixels probably. Stroke width 4, 6, 4, 5, 6. Instead of using line SVG tag, you could use the SVG tag path, move, and then line. So move would be X and Y, and line would be, so move would be X1 and Y1 pair, and line would be the uppercase one, the absolute one would be x2 and y2. But this also allows you to work relatively. Like in this case, if you want something horizontal, you're not going to variate the y relatively to the x1 y to the y1, which is 40 in this case. So it's even a simpler way to define lines path than SVG line tag. We saw stroke opacity, stroke line cap, the end of the stroke, butt, round, and square. These things are important, and you will probably encounter them if you're going to use an SVG editor application. Butt, rounded, and square. If you want text with outline, you're going to encounter this stroke line cap. Dash array, comma or space separated list of length percentages that define the lengths of dashes and gaps. Let's see how that works. So stroke dash array, comma separated list of length and percentage. So that would be 5 pixels red and then 5 pixels gap. 5 pixels red, 5 pixels gap. This would be 10 wide and then 10 gap, 10 wide, 10 gap. Okay, makes sense, the stroke dash array. For the outline, which is the stroke. Defines the shapes of the corner where two lines meet. So something similar to the RX. What was the thing for a rectangle, for rect, where you can make rounded rectangle, RX and RY. Arcs, bevel, meter clip, round. You will encounter this if you use a SVG editor application such as Inkscape. Filters. Inside devs, used to add special effects to SVG graphics. FE, Gaussian blur. Wow, this is diving into programming with SVG. So similar to a predefined function. Source graphic. Filter ID. You references with URL. It says the rectangle, which has width, height, and fill. You'll need to apply to it this thing, which is the Gaussian blur, standard deviation 15, at x is 0 and y is 0. List of functions, filter effects, blend, color matrix, component transfer, composite, wow, drop shadow, flood, image, merge node. turbulence. You can use multiple filter effects on each SVG item. Blur effects. Standard deviation defines the amount of blur. Drop shadow. Load opacity. So this is, the shadow is not just all black, it's transparent. And the shadow has the interesting pixels here and here. Offset and blend. Offset and blend. And it's running both functions inside a single filter with a single name. And probably in this order. First a offset and then a blend. So however you define the rect, it will be a double will be created by creating a copy with this offset, and then you say that the original should be on top. Blur with Gaussian blur. And blend and offset. Okay. Make the shadow black. Offset, Gaussian blur, and blend. Shadow as a color matrix. Just one filter, offset, color matrix, Gaussian blur, blend. Linear gradients, very important part of working with SVGs. Sometimes you're using SVGs just to create gradients. Maybe you just need a small image that's perfectly resizable that only contains a linear gradient. Radial gradient and linear gradient. Ellipse, horizontal linear gradient that goes from yellow to red, so goes from here to here. Starts yellow, ends red. Stop 1, stop 2, yellow, red. Offset from I know what this thing is. X1, Y1 is 0, 0, and X2, Y2 is 100%, and Y is 0%. Yeah, so this way you're defining the gradient just once, and then you can apply to not only an ellipse, but also a circle, text, etc. Because everything has a 0%, a 100%. Horizontal linear gradient. Horizontal. This is with 3 colors. So it has 3 stops: 0, 5, 50% and 100%. So very similar to what was above, but just this extra line. Stop offset 50%. Up, down, vertical. Specifies the x1, y1, which is this, and x2, y2, which is this. So x remains value 0, but then y advances to the 100%. So this makes it vertical, not horizontal. This we saw before, this we saw before. Horizontal linear gradient with text. x1, y1 is this. x2 is this, y2 is this. So it's horizontal. Only 2 colors. There's an ellipse that uses the gradient, and then on top there's a text. And there's also the possibility of going in the diagonal. So in this case, it's x1, y1, 0, and y1, 100. So it starts from this position, bottom left, and then goes to x to 100%, which is this one, and y to 0, which is top right. So this is the direction of the gradient. Radial gradient, what you would expect, 2 offsets, and the gradient is specified not with x1, y1, x2, y2, but something similar to the circle. There's a cx, cy, and r. Three stops. This is an interesting one. Cx, cy, 25%. Spread method reflect. So there's this attribute spread method. One of the possible values is reflect. So it's what was before, cx, cy, both 25%. But then it uses spread method reflect to create this part of the globe. Repeat radial gradients. Radial gradient from red to blue. Okay. Next, pattern. Graphic that is redrawn to cover an area. Let's see how that works. So there's a single circle, and then you say rect fill URL of pattern 1. Pattern units user space on use. Where does it say that it should repeat horizontally and vertically? Maybe that's the whole point of pattern. Pattern with gradient. Fill URL pattern 2, which is this thing. This contains a circle, but we also want background for the circle. So under the circle we put a rectangle with fill light blue. And then we use the gradient as the fill for the circle. Oh. Transformations for the SVG: translate, scale, rotate, skew X, Y, and matrix. We already saw transformation rotate, to rotate the text. So that was transform and then rotate with 30 degrees. Translate 5 and 0 is going to move the object, which in this case is the rect. So we have two rects at the exact same coordinates, x, y, width, and height. But then we say, instead of painting the rectangle where it should, paint it in a different place, which is translate all of the x's with plus 50 and the y's to with nothing. So effectively moves the red rectangle, which was on top of the blue, and the blue rectangle is not visible at all, 50 pixels towards the right. Okay, you can translate plus 50 on OX axis, plus 50 on OY axis. So it moves on the diagonal. Scale, transform scale to, so it almost paints a red identical circle, not a red circle, but immediately before actually outputting it to the screen, it increases the scale by 2, which means the R becomes 40 and I'm not sure how the CX and CY changes. Obviously CY changes because this is the center of the rendered circle and this is the center of the yellow not transformed, not scaled circle. There's a circle and we scale it not equally. Vertically we scale it, but horizontally not. So the width remains the original width, which is 40, 2 times the radius 20, but then the height becomes 80 instead of just 40, with scale and then comma 2. Scale 2, comma 1. Rotate 45 degrees, rotate 45. Skew X 30 degrees. Skew Y 30 degrees. Okay. Next, clipping and masking. Let's see an example. So we have a circle and we want to not display everything, so we're going to clip half of it. We're not showing the bottom of the circle. Clip path, URL cut bottom, and we're just putting a rectangle that's, fill white. Let's see, are rectangles fill white by default? No, they're fill black by default. This rect element would cover the upper half of the circle. The rect will not be drawn, instead its size and position will be used to determine the pixels of the circle that will be shown. Since the rectangle covers only the upper half, the lower half will not be shown. And masking. Let's see what that does. There's a rectangle that has stroke black and another rectangle that's fill red. And the two rectangles have the same coordinates and size. I'm not sure what's happening here. So there's a rectangle that's fill none, which means it's what? Transparent. It only has a stroke black, so this is the rectangle, the stroke. And that we have a rectangle that's half red, half white. White from the mask and red from the fill. Okay. So mask is like layers. We show a circle that's white. And the white pixels are what's visible from the rectangle probably. So only this circle is visible from this entire rectangle that's filled red. Okay. Fill color and opacity. Fill with hexadecimals. Gradients in masks. If it's white, it's visible. If it's semi-white, it's semi-transparent. Otherwise, it's not painted at all. Fill red. So these pixels of the mask are perfectly white and these pixels are perfectly black. Stop offset 100% and black. SVG animation. Begin 3 seconds. I'm not sure why this thing does not work. Okay, a circle that moves. Animates the CX, so the X coordinate of the center. Seconds for begin duration from 2 and repeats forever. Yeah, cool. Fill is freeze. So this probably moves and then remains at a last position. Animate transform. Let's see if this example actually works in Visual Studio Code. And it does. Oh. And it should stop at the rightmost position. Okay. Then what does this thing do? So after 30 seconds, it will set the radius to 50 and it was 25 at the start. Yeah, it does work. SVG animate transform. Rotate type indefinite. Animate motion. Well, so it has a path with a move, quadratic, and another quadratic. So it does a sinusoidal dance. We could mix SVG and JavaScript if we're using SVG inside HTML. There's a button that changes the radius. How does it do that? Document get element by ID, so the SVG tags are part of the HTML DOM, document object model. It fetches ID circle1, which is this guy, and it changes the value of the attribute from R25 to 50. Input type button on click change radius. Cool. Change CSS changes the style fill from red to green. Change attribute values and CSS. So get circle 3, which is this guy, and sets attributes, radius CX, but also the style, which is the CSS. Fill from red goes to green, and stroke becomes red. Yeah, makes sense. Start and stop the animation. So get circle 4, gets attribute CX, and it sets it to the correct value to animate. And then there's a timer which makes the function, which calls the function, which just changes the value of the x coordinate of the circle, of the center of the circle. The start button starts the timer, we set interval, and the stop stops the timer with clear interval. And T is a timer created here and cleaned up here. quadratic Bezier curve. And this should be it. So let's see what we saw. This was a tutorial from w3schools about how to use SVG inside HTML. So inside an HTML web page, you might have tags which are from the various versions of the HTML specification. You could have JavaScript, you could have CSS, which is for instance, inline inside a HTML tag, you can have the attribute style, but then you can have additional tags inside an HTML page, such as the ones from the SVG specification. You can have an SVG viewport, which is this thing, and inside you can use tags which are covered by the namespace www.w3.org/2000/svg, such as rect, which is a rectangle, circle, line, text, polyline, path, etc. Inside text, you can have subparts of the text. You can place text along paths. You can run functions on the various SVG elements. You can animate. You can use JavaScript to change attributes and styles of the SVG items, because the SVG items are inside an HTML page and are part of the document object model. And we also used a bit of tooling for making it easier for us to see what's happening. We have used Visual Studio Code as an integrated development environment. By default knows how to work with HTML, but doesn't know how to provide autocompletion values for SVG tags. For that, we have installed the Visual Studio Code extension named SVG. This has also provided documentation if you hover on top of SVG tags. So if you hover on top of HTML tags, you get the documentation probably built-in from Visual Studio Code. But if you hover on top of an identifier that's part of the SVG specification, you're getting documentation pop-ups from the SVG extension of Visual Studio Code. And then, in order to see live what changes we do inside the HTML page without even saving the page, we're using another Visual Studio extension, which is the one from Microsoft, the live preview. So this is it. It might come in handy to be able to know what's possible with the SVG specification inside HTML. You might want to create graphics or logos or backgrounds that use patterns, that use clipping, that use gradients, that will be responsive and will work correctly on various form factors, on a mobile phone, on a large TV set, etc. And it's important to know that you have these capabilities inside SVG, inside HTML, to work with them a bit But then for very advanced graphics, using SVG, you would use a SVG graphical user interface text editor, user interface editor, so an image editor that is SVG native, such as the Inkscape tool. And then the source code, the XML source code, the SVG source code that's being generated by Inkscape, when you save the file, you can just copy paste parts of those into your HTML page inside the SVG tab. But make sure that you're using the subset of SVG that's supported both by Inkscape and by the HTML standard and by the individual web browsers. Thank you.